Hello students, today we'll be learning about how to draw the ray diagrams for concave mirror. And you are all familiar with the concept of the ray diagrams now, that they give us the details of the image formed by the concave mirror. Like we can get to know about the position of the image and the size of the image and whether the image is real or virtual by drawing the ray diagrams. So for drawing any ray diagrams for concave mirror or convex mirror, we need to consider three rays basically. The first ray is the ray that is coming parallel to principal axis. The ray of light that comes parallel to principal axis, after reflection, it passes through the focus of the mirror. We need to remember these three rays, that the ray coming parallel to principal axis after reflection passes through the focus of the mirror. And second ray of light we take that comes through the focus. Now the rays that come through the focus of the mirror after reflection, they get parallel to the principal axis. Just the opposite case of the first one. So in the first case, we had read that rays coming parallel to principal axis after reflection pass through the focus of the mirror. And if the ray of light is coming through the focus of the mirror, then after reflection, the rays will get parallel to the principal axis. And the third ray that we are going to take for the image formation, we are going to consider is the ray that comes through the center of curvature. So this ray after reflection, it will just go back in the same direction. Means it will go back through the center of curvature again. After reflection, it will go back in the same direction. Now, we are going to use these three rays for the image formation by the concave mirrors. So let's consider the first case now. So first case is if the object is at infinity. Means if the object is very far off from us, so how is the image going to be formed? So let's consider this mirror. This is a concave mirror, and the center of that mirror we take it as pole, and then the line passing through this pole is called the principal axis. And for our convenience for drawing the ray diagrams, I have told you that we can take the distances of the focus or the center of curvature from the pole as 2 centimeters, because the distance of the pole from focus and the focus from the center of curvature, it is equal. Focus is just the half of the distance of center of curvature, the radius of the mirror. So I'm taking 2 centimeters for my convenience so that my diagrams comes out to be perfect. So here is my focus, and the next point I'm going to mark again at the distance of 2 centimeters from the focus. That will be my center of curvature. So this is my focus and this is my center of curvature. Now I have told in the first condition that the object is at infinity. So what's going to happen here? So my object is here at an infinite distance from the mirror. So it might be a larger one also. I can draw it like this. And when we are drawing the rays of the light, we are going to take the ray. If I'm taking a parallel ray, I'm going to take it from the tip of the object. So this arrow shows my object, and I'm going to take my first parallel ray from the tip of the object, and it has to strike the mirror. It has to reach till the mirror, because here is the point where the reflection is going to take place. अगर आप इसको mirror तक पूरा नहीं लेके जाएंगे, that means your reflection is not there, because if it is striking the mirror, then only it is getting reflected. Okay, so you have to make sure that you take the first ray from the tip of the object, and it has to reach the mirror, and then after striking the mirror from this point, it will pass through the focus of the mirror. So this way your ray is going to pass through the focus. Now this is a reflected ray, the arrow is showing the direction, and this is the incident ray, again the arrow is showing the direction. So second ray, again I'm going to take parallel, because I know my object is very far off, and obviously it will not be in the vicinity of the mirror. It will not be like the light will not be able to come through the center of curvature or through the focus. It's very far off. So again I'm taking a parallel ray, like the rays are coming from very far off place. Again another parallel ray from the bottom of the object I'm taking. So it's parallel to principal axis again. So that means after striking the mirror, it will be reflected through the focus. So again I have to join this point where it is meeting the mirror and the focus. So here it is going back. So if I see it clearly, the both of the reflected rays, they are meeting at this point, which is the focus of the mirror. So we have to see where the reflected rays are meeting after reflection. That point will define the place where the image is going to be formed. So my image is at the focus, but if I see it clearly, it's just like a dot, because there is no distance upwards from the principal axis, there is no distance downwards from the principal axis. So that means if the object is at infinity, the image is going to be very, very small, just like a dot, and it's going to be at the focus. So this is my first description of the image formed when the object is at infinity. So object is at infinity, the image will be real, but it will be very, very diminished in size, very small in size. Now let's consider the second case. Dear students, let's discuss the second case of ray diagram. This is the case when the object is lying beyond the sea. Or center of curvature. Let's see how to draw it. This is my concave mirror, and I have marked the central point as P, pole of the mirror. Now I'll be drawing a line passing through the pole of the mirror as the principal axis, and then I'll be taking distances of 2 centimeters, 2 centimeters from the pole to mark a point it is focused, and again 2 centimeters from the focus that to mark the point center of curvature. So these are my denominations of center of curvature, focus and pole. Then my object will be beyond C here. So this is how I'm going to make my object, which is upright or erect, and I'm going to name it as AB. And then I'll be using those 3 rays to draw. You can use any 2 rays to draw the image for the ray diagrams. So one ray coming from the top of the object parallel to the principal axis, it will be passing through the focus of the mirror after reflection. So we have to very carefully join these 2 points and draw the ray, that is the reflected ray. This is the incident ray. Now second ray of light will be coming through the focus of the mirror, again from the tip of the object, through the focus, striking the mirror, and after striking the mirror it is going to get parallel to the principal axis as per the rules. So this is going to pass through here, and if I see both the reflected rays, they are meeting at this point. So I'll be joining this point to the principal axis with a straight line like this. Now these lines are meeting below the principal axis. This is my principal axis, and these reflected rays are meeting below the principal axis. So that means my image is formed below the principal axis. So it will be inverted. If the rays of light meet above the principal axis, that means the image is going to be erect. but now they're meeting below the principal axis, so the image is inverted. It is real because the lines are actually meeting. We don't have to produce the lines anywhere. And if we see the sizes, if you compare the size of the object with that of the image, we can see that the image is smaller than the object. So we can rename the image as A dash and B dash just to show its position and the size and the nature. Nature is real and inverted, size is smaller than the object, and it is real and between C and F. So if object is beyond C, the image will be between C and F. Let's try to draw the third condition, which is when the object is lying at the center of curvature. C or center of curvature. So we'll start with the same procedure. We'll draw a concave mirror with free hand only. Then we'll locate its central point and mark it as P, that is the pole of the mirror. Then the line, imaginary line that passes through the pole is called principal axis. So we'll draw the principal axis of the mirror, and then 2 points that are at a distance of 2 centimeters from the pole and 4 centimeters from the pole. These are focus and center of curvature. And now my object is lying at the center of curvature. This is my object, standing upright and represented by the letters AB. So here comes the first ray of incidence, the ray of light coming parallel to principal axis. And after striking the mirror, it will be going, this is the focus, it will be going through the focus. This is my reflected light. And then second ray of light will be coming through the focus only. And after reflection from the mirror, it will be going parallel to the principal axis. So very carefully we have to draw the line. So this is the mark. I think slightly tilted, so I have to see my scale is straight, and then I'll be joining this as straight line. So I can see the lines are meeting here. So this is the point of intersection of the two reflected rays, and if I join this point with the principal axis with a straight line, so I find that it is almost there at the center of curvature. So you can say that if the object is lying at the center of curvature, then the image of the object will also be at the center of curvature, and it will be of the same size but inverted because the image has been formed below the principal axis. So you can say the slight variation is there because somewhere my line got tilted. You can see here this line which was coming along the line of the diary, it has gone little away. So if I was to draw it exactly in a straight line, then definitely the lines would have meted over here, and that was my center of curvature. So this way you can form the image, but the sizes of the images are same. Image is inverted, real, and at the center of curvature only. So this is the third condition when the object lies at the center of curvature. And here it is clearly visible now that these lines are meeting at this point. So if I, because again this point is below the principal axis, so if I draw a line, straight line joining this point to the principal axis, this will be my image. Because it is below the principal axis, that means it is inverted. And if I see the position of the image now, my object was lying between C and F, so my image has gone beyond C, and the image is inverted. It's real because the lines are actually meeting. And if I see the sizes of this object and image, I'll find out that the size of the image is now bigger than the object. So this is my description of the image formed when the object is lying between C and F. Now let's find out what is the next condition. Our fifth condition for drawing a ray diagram is when the object lies at focus. So now again we will be drawing a ray diagram to find out the location and the details of the image. This is my concave mirror, and I'll mark my pole over here roundabout in the center of the mirror, and then an imaginary line joining the pole or passing through the pole of the mirror is the principal axis, and then 2 points on the principal axis that are at a distance of 2 centimeters from the pole, and the other point is 2 centimeters from the focus. So this is my focus, this is my center of curvature. Now my object is lying at focus, exactly at focus. So here is my object this time, and again I'll be drawing the rays to show my image formation. One ray of light which is parallel to principal axis, it will be passing through the focus. This is my reflected ray. Now another ray of light I cannot draw from the focus because my object is lying already at the focus. So I can do one thing, I can draw the other ray of light from the center of curvature itself. So from the tip of the object I'm going to draw a line, and we know that the ray of light that passes through the center of curvature, it goes back in the same direction. I can't see these lines meeting anywhere in front of the mirror because they are going parallel to each other. We can see they are almost parallel to each other. So if I try to extend these lines backwards to see if they are meeting at the back of the mirror, so I'll try to find out. And if I'm extending the lines backward, I have to draw dotted lines because in this case the lines are actually not meeting but they're going back. A straight line. You can see these lines are just running parallel and they might meet at infinity. So if my object is lying at the focus, that means the rays of light don't meet anywhere in front of the mirror or at the back of the mirror, but the reflected rays, they run parallel to each other. So they might be meeting somewhere at infinity. We don't know, we don't have any idea about it. So that means the image formed will be at infinity. So if the object is at focus, the image will be at infinity. It's just the opposite case of the first one, in which we discussed that if the object is at infinity, the image formation was there at focus. But now the object is at focus, so that means the image formation will take place at infinity. Now let's consider the sixth case. When the object lies between focus and pole. I have to draw with me so that you can understand the concept. And again I have drawn the pole. I marked the point P at the center of the mirror, and that point P represents the pole of the mirror. and this is my principal axis. The line passing through the pole, straight line passing through the pole of the mirror is principal axis, and then I'll be marking my focus and center of curvature. This is my focus, this is my center of curvature. So they should be exactly 2 centimeters from each other. Focus will be 2 centimeters from pole and center of curvature will be 2 centimeters from the focus. Now my object is lying between F and P, so that means somewhere here. This is my object. And if I had to draw the lines, rays again to show the image formation, I'm going to make first line parallel to principal axis, and then it will be reflected through the focus. Like this. Now another ray of light that is coming through the center of curvature. You can see these lines are again not meeting in front of the mirror. Let's try to extend them backwards. That means these lines are meeting just behind the mirror. So now the point is here where the lines are meeting, and if I join this point with the principal axis with a straight line, so it is again this image formation has taken place above the principal axis because the lines are appearing to meet behind the mirror and above the principal axis, so the image will be upright, it will not be inverted, but because the lines are not actually meeting, so this is a virtual image. It's virtual because we have to produce the lines at the back, and then image is virtual, it is erect, and again between F and P. If suppose this is F, it will be between F and P only, but the image will be much larger than the object. So much larger than the object.